Hello everyone. In this session, we are going to talk about how to solve pulley problems. So here we have a simple pulley where two masses M and 2M are attached to each other with a string. Now this string is passing over a pulley like this. Now in such problems, and most of the 99% of the problems that we will deal with in physics, the pulley is taken to be massless and frictionless. Why is it so? It is because to simplify the calculation. And it is because of this assumption we can say the tension in this side of the string and this side of the string both are equal. Okay. So otherwise we cannot do that. So now let's talk about this simple pulley problem. Okay, here we have this simple pulley. There are two masses M and 2M attached to the string. Now here if we see what is the pulling force which is acting downwards on the mass 2M, the pulling force downwards is 2mg. Okay, and here for this particular mass the pulling force downwards is mg. Okay, now the net pulling force will be 2mg minus mg. So let me keep this system like this, horizontal. Okay, there is this mass m and there is another mass 2m. Okay, now here in the two masses the tension will be same. Okay, because this is a same string, and whenever there is a same string then the tension throughout the string will be equal. Okay, it is due to the assumption that the pulley is massless and frictionless. Now here if we take 2mg force towards right like this acting on the 2m block, and then there will be this mg force which is in the left direction. So what is the net direction of the force? Obviously there are tension forces like this on masses m to and 2m. So as you know, tension is always a pulling force, so it will be upwards for both these cases. Now what is the total force in right direction? So total force will be in right direction, which is 2mg minus mg. So this is our net force, which is equal to mg. Okay, so total net force is mg downwards. Now here, what is the total mass? Total mass is 2m plus m, that is 3m. So the acceleration of the blocks will be net force divided by total mass. Total mass. So this is equal to mg divided by 3m. So this will become g by 3. So here the acceleration of the 2m block is g by 3 downwards, and the acceleration of the small m mass is g by 3 upwards. So what we have done here, we have taken this problem in the form of a horizontal blocks, horizontal direction. The blocks are kept in a horizontal direction, and on the block 2m there is a pulling force 2mg downwards. On the block m there is a mg force pulling downwards. So the net downward pulling force is 2mg minus mg, because 2m is pulled down by 2mg and this one is in the opposite direction mg. That is here if you can see the mg is towards left direction and 2mg is towards right. So the net force will be in the right direction, that is 2mg minus mg. So this is the net force, and we have to divide this by total mass. Then we will get the acceleration g by 3. Now how to find the tension? So here if you draw the free body diagram of any of these masses, you will get the acceleration. So let's do it for mass 2m. So here this is mass 2m. So I will draw the free body diagram like this. The tension force is upward and 2mg force is downward. And now the block is going downwards with the acceleration of g by 3. So according to the Newton's law, the total force is ma. So 2mg minus t is equal to m into g by 3. Because 2mg is greater than t, so 2mg minus t will become mg by 3. So this tension T will be equal to 2mg minus mg by 3. So this will become 5mg by 3. So this is the tension acting on the blocks. Okay. So here same tension will act on the mass m. as well. Okay, let's look at another pulley problem. So here we have three blocks, okay, and two strings. Okay, here is one string and here is another string. One thing I want you to remember is that the tension along the string is same throughout, but now here there is a discontinuity. There is a 4 kg block between this string and this string. So here throughout this string the tension will be equal, but it will be different than the string which is above the 4 kg block. Okay, so the tension in the string above this 4 kg block will be different, and tension below this tension of the string below this 4 kg block will be different. Okay, so we have to keep into mind that. Now what we have to find is acceleration. Okay, and for simplicity we will assume g is 10 meter per second square and the pulley is frictionless and massless. Okay, now what is the acceleration A? Now same method we will do. We will find out the net pulling force downwards on this right hand side. It is 8 times g minus the net pulling force downward pulling force on 2 kg mass, which is minus 2g. Okay, so you can make the picture horizontal direction picture in your head. Okay, so I am not drawing that now. So this is the net force now divided by total mass. So total mass is 4 plus 4 8 plus 2 10. So this is total mass 10. So this is 6g by 10. So this is equal to 6 into 10 by 10, that is 6 meter per second square. So the acceleration of these masses is 6 meter per second square. Okay, all masses will accelerate with the same rate. Okay, now what we have to find is tension in the string. So let's say the tension in this string is T, and let's say the tension in this string is T dash. Okay, now if we draw the free body diagram we will get the answer. So let's do it. So here the tension is also T because it is the same string. So now T, since if I draw the free body diagram of mass 2, what I will get? I will draw the free body diagram of mass 2. This is mass 2. Okay, upward direction force will be there, tension. Downward force will be there, which is 2g, which is the gravitational force acting on that. Now T minus 2g is equal to 2a. Why T minus 2g? Because T is upward direction, T is in upward direction, 2g is in downward direction, and mass of 2 kg is going upwards. So T is equal to 2 times g plus 2 times a. But a is 6 and g is 10. So here it will be 2 into 10 plus 2 into 6. That is 20 plus 12. That is 32 Newton. So the tension in this string is 32 Newton. What about T dash? So to find out T dash, again we have to draw a free body diagram for the block 4 kg, which is this one. Okay, there are 4 kg, two 4 kg blocks by the way. We will draw the free body diagram for this 4 kg block. So here it will be 4, downward force is 4g and upward force is T dash. There is no other force and this block is going downwards with the acceleration 6 meter per second square. So we will have 4g minus T dash is equal to 4 into 6. So this will become 4g minus 24 is equal to T dash. That is 40 minus 24 is equal to T dash. So this will become 16 Newton. So T dash is equal to 16 Newton. So T dash is 16 and T is 32 Newton. So these are the answers.